Good morning, everyone. I hope you are doing well. सुबह सुबह सब सोच रहा होगा क्या कर रहा है सुबह सुबह सब सोच रहा होगा क्या कर रहा है तो 5 o'clock में स्टार्ट करेंगे अपना सेशन और 50 मिनट्स के बाद ब्रेक लेंगे थोड़ा ओके यही अभी रहेगा और 5 o'clock में स्टार्ट करेंगे अपना सेशन और 50 मिनट्स के बाद ब्रेक लेंगे थोड़ा 10 मिनट का हाय भाई हाय जो भी लाइव चैट किया उसको हम अभी बोल के रिप्लाई कर रहे हैं 10 मिनट का हाय भाई हाय जो भी लाइव चैट किया उसको हम अभी बोल के रिप्लाई कर रहे हैं 10 मिनट गुड मॉर्निंग इतना सुबह आप उठे हैं यूट्यूब खोले हैं और हमको देख रहे हैं प्रीलिम मेरा सीसेट की वजह से रुक रहा था तो यदि आप रिप्लाई कर दे भाई 2 मिनट अरे भाई सेट कर रहे थे सब कुछ सेट नहीं करेंगे तो फायदा नहीं होगा फिर तो क्लास ही करेंगे भाई बिल्कुल अरे भाई सेट कर रहे थे सब कुछ सेट नहीं करेंगे तो फायदा नहीं होगा फिर तो
चलिए, let us start. Temperature, salinity, it was done. Now we are moving to density of water, sea water. Density of sea water. How much is the density of water?
1.
1. Right? Density of water 1.000, at least 3 at 4 decimal point तक लेते grams per cubic centimeter. At least we'll take up to 3 decimal points, or we can take it up to 4 also. But what is this one density of water? Pure water. Pure water समझते हैं, कोई भी dissolved substance उसमें नहीं है, and temperature is 4 degrees Celsius. कहते हैं water has maximum density at 4 degrees Celsius. So among the properties of water that you would have studied in your school days, पढ़ोगे ना, odorless, tasteless, colorless, and एक property ये भी पढ़ा होगा आपने, water shows anomalous behavior. Anomalous behavior means normally density of any substance, water suppose, increases with decrease in temperature. कम करते रहेंगे तो density बढ़ता रहेगा because contraction होता रहेगा. Particles will be tightly packed, so density will increase. This statement is true for water only up to 4 degrees Celsius. जब भी temperature 4 डिग्री से कम होगा, अब density बढ़ने के बजाय कम होना लगेगा. That is anomalous behavior of water. And that is why ice floats on surface of water, क्योंकि ice का density कम होगा. कायदे से तो temperature कम है ice का, तो density should have been higher, but that is what is the difference that water shows anomalous behavior. अब जो भी discussion हम अब के बाद करेंगे, उसका एक break point क्या होगा? 4 degrees Celsius of temperature. We will not be discussing temperature less than 4 degrees Celsius because then the conditions will change. And anyways, the temperature of water, आपने horizontal distribution देखा आपने temperature का, या maps देखा होगा आपने, कहीं पर भी आप नहीं देखेंगे कि temperature is 0 or -2 or -3 except for the Arctic frozen water. हर जगह temperature आपको 5 degree, 10 degree and more than that you will find. So 4 degrees Celsius is out of question, so we'll rule out this below 4 degrees Celsius. जो भी discussion होगा वो 4 degree Celsius के within होगा. So what are factors that determine the density of water? किन factors पर पानी का density depend करेगा? Temperature, isn't it? This is easy. Temperature. Second factor, salinity. Salinity. So we can very easily understand this. कोई difficult point नहीं है. The density of water is directly proportional to salinity and inversely proportional to temperature. Less temperature would increase density, higher salinity will increase density. But there is fourth factor that you can say external factors that will increase the density of water. That external factor is atmospheric pressure. The pressure will increase density. चाहे वो atmospheric pressure की बात कर रहे हो या the hydrostatic pressure of the water itself. Because पानी का अपना भी तो pressure है. आप ocean bed पे जाएंगे तो water will exert a lot of pressure even if the salinity is same, density is same, we may have very dense water. Why this dense water is there is because there is intense amount of pressure or compression that we experience at the. So there is a internal compression in water. इस internal compression को अगर high pressure मिल गया, atmospheric high pressure, the density of water will be quite high in that case. तो तीन factors हैं जो density of sea water को determine करेंगे. दो factors वो हैं जो which are internal to the water and one is external to the water, that is atmospheric pressure. So we are going to write these factors first and write some values, they are important. फिर एक interesting diagram देखेंगे where we represent temperature, salinity and density of water. We call it as TS diagram. So we will be drawing this kind of a diagram. एक तरफ temperature represent करेंगे, एक तरफ salinity represent करेंगे, and these lines are isopycnal lines. Lines which shows same density. हम इसको calculate करेंगे तो it is easy for us to represent. तो पहले ये देखना है कि salinity और temperature का effect क्या है density पर, then zonation of water, and based on zonation we'll draw these lines, right? So it is actually the property of sea water that we are discussing. तो अगर मेरे पास ये point लिखना है मुझे, the property of sea water, so I'll write about density of sea water depending on salinity, temperature, pressure and so on. या फिर थोड़ा और addition करेंगे, concentration of oxygen लिखेंगे, concentration of carbon dioxide लिखेंगे. So let's write down one by one. Density of water, one of the characteristic feature of sea water. So we'll introduce these lines one by one. Density of water is an important characteristics of sea water. Important characteristics of sea water that decides whether the water will float or sink. Whether the water will float, sea water will float or sink. Whether the water will float or sink. Whether the water will float, sea water will float or sink. Full stop. The rate of sinking is determined by relative density of water. Relative density of water and the resistance it experiences. Relative density of water. Relative density of water and the resistance it experiences while moving to deeper layers. क्या resistance हो सकता है पानी में? Suppose there's a water mass which is a denser water mass, relatively denser water mass compared to the lower region if the density is higher. और हम कह रहे हैं कि अगर density ज़्यादा है it will experience resistance. What resistance is that? Buoyancy. Buoyancy किस पे depend करेगा दोबारा? Temperature पर और density. Yes, simply we can say density. Also, what is the present, like what are minerals present in it? Dust particles है या नहीं है? Mud particles है या नहीं है? That will determine the resistance of that water mass while sinking. अब जब तक ये नहीं पढ़ेंगे हम कि डेंसिटी और ये कंडीशंस कैसे होंगी तब तक हम वाटर मासेस को नहीं डिस्कस कर पाएंगे. So it is, this topic is very important to understand water masses. right? And water masses is a topic that will be very, very important topic. देखिए, three factors that determine three factors: control density of water, Number one is temperature. Underline this. Number one, temperature. Temperature and density have inverse relation up to 4 degrees Celsius. Up to 4 degrees Celsius. Also, when the seawater is heated, it undergoes thermal expansion. Causing reduction in density. Seawater is heated. It undergoes thermal expansion. Causing reduction in density. On the other hand, decrease in temperature brings thermal contraction. Density of water increases. Full stop. It is applicable only to tropical and subtropical latitude. Of water increases. Full stop. It is applicable only to tropical and subtropical latitudes. Applicable only to tropical and subtropical latitudes. Because in higher latitudes, it freezes. Because in higher latitudes, it freezes, shows anomalous behavior. That is, density of water decreases as temperature decreases below 4 degrees Celsius.
As temperature
Decreases as temperature decreases below 4 degrees Celsius. Full stop. According to Thurman and Trujillo, Thurman and Trujillo, a change in temperature of warm low latitudes has about a change in temperature of warm low latitudes change in temperature of warm low latitudes has about 3 times effect on density of equal change in temperature in colder latitudes or simply higher latitudes. Of equal change in temperature in colder latitudes or simply higher latitudes. Then comes next factor, that is
Salinity.
salinity. Increase in salinity increases density of water. Increase in salinity increases density of water the positive relation between density and salinity is due to the fact that salt adds molecular weight of water. Is due to the fact that salt adds molecular weight of water. Okay. So इन दो factors को देखें, so we can write that density of water is directly proportional to salinity
or inversely proportional to temperature.
and inversely proportional to
Temperature.
temperature. And inversely proportional to temperature. कोई confusion नहीं इसमें?
No, sir.
याद रखना जो bracket होगा that will be 4 degrees Celsius. It is not below 4 degrees Celsius. Density of water proportional to salinity and temperature. इन दोनों में से किसको ज्यादा डोमिनेट मानेंगे आप, सैलिनिटी को या टेम्परेचर को? Which one is more dynamic, सैलिनिटी और टेम्परेचर? सैलिनिटी ज्यादा डायनेमिक है, क्यों?
अलग-अलग ओशंस के अलग-अलग है.
पोल्स पे टेम्परेचर ओके, मतलब टेम्परेचर चेंज होता है तो डायनेमिक तो टेम्परेचर हुआ. डायनेमिक फैक्टर समझ रहे हैं ना, which will not remain constant, which keeps on changing. तो सैलिनिटी और टेम्परेचर में किसमें ज्यादा मानेंगे आप, कौन ज्यादा फैक्टर डोमिनेंट होगा?
टेम्परेचर ही होगा.
या पहले डायनेमिक होगा. टेम्परेचर, डे एंड नाइट टेम्परेचर विल बी डिफरेंट. लैटिट्यूडनल टेम्परेचर इज डिफरेंट.
मेन
तो
लैटिट्यूड
डोमिनेंट फैक्टर कौन बनेगा?
टेम्परेचर.
डेंसिटी चेंज होगा तो सैलिनिटी विल ऑलवेज बी देयर. इतना जल्दी सैलिनिटी चेंज नहीं होगा. तो if the density of water is changing, it is largely changing because of temperature. Dynamic factor किसका होगा? I mean temperature. So if the sea water undergoes a continuous change in temperature, that will also bring a continuous change in density of water. Not clear? So dynamic is temperature, so density, otherwise density of water should always remain constant. At a given latitude, the density of water should not change, it should remain always constant. अगर एक लैटिट्यूड में एक ही जगह में डेंसिटी पानी का चेंज होता है तो किसके कारण चेंज होगा, सैलिनिटी या टेम्परेचर, राइट? होने को तो दोनों के कारण होगा, बट सिंस टेम्परेचर इज मोर डोमिनेंट और मोर डायनेमिक, इट विल बी अ डिटरमाइनिंग फैक्टर फॉर चेंजिंग ऑफ डेंसिटी इन एनी गिवन रीजन. क्योंकि सैलिनिटी इतनी जल्दी चेंज नहीं होता है, 35 पार्ट्स पर 1000 है तो उतना ही रहेगा. लेकिन टेम्परेचर पर 10 डिग्री सेल्सियस, इट कैन बिकम 15, इट कैन बिकम 20, इट कैन डिक्रीज, राइट? सो ब्रॉडली देखो अगर आप, तो एक फैक्टर सबसे ज्यादा डोमिनेंट है डेंसिटी को चेंज करने के लिए, एंड दैट इज गोइंग टू बी टेम्परेचर. अगर मुझे डेंसिटी ऑफ सी वाटर पढ़ना है तो मैं सैलिनिटी को इग्नोर करूंगा, मैं उतना ज्यादा ध्यान नहीं दूंगा सैलिनिटी पर, क्योंकि मुझे पता है वो कांस्टेंट रहने वाला है. चेंज क्या होगा, टेम्परेचर चेंज होगा, तो आई विल बी मोर कंसर्न, मोर फोकस्ड ऑन टेम्परेचर. Not okay? Okay, at this line, although the effect of this, okay, although the effect of temperature on density is more pronounced, you mentioned this, okay, although the effect of temperature on density is more pronounced than salinity because it is more dynamic factor and causes thermal expansion or contraction. This more dynamic factor and causes thermal expansion or contraction. Let's see it this way. We have a pool of water, any container of water, and you keep on adding salt to it. आप अपने इतना salt add कर दिए इसमें कि इसमें further addition of salt possible नहीं है. You increase the temperature of this. If you increase the temperature of the same water, what is going to happen? Solubility will increase. Expansion होगा ज़्यादा salt. और increase करोगे temperature तो salinity will again change. So dynamic factor is going to be temperature. Dominant factor is going to be temperature, because even the solubility of water will be determined by the temperature level. Third factor of it is pressure. It's easier point that high atmospheric pressure it's easier point that high atmospheric pressure brings contraction on the surface of water, point that high atmospheric pressure brings contraction on the surface of water, leading to the increase in density. So if I take this particular density, leading to increase in density, so if I take this particular point, I can also say that subtropical high pressure region should be denser. दोनों जगह सैलिनिटी सेम मान लेते हैं, हालांकि सैलिनिटी भी यहाँ ज्यादा होता है. Let's suppose salinity is same 35 at equator, 35 subtropical high pressure zone. Subtropical high pressure zone will be having denser water because there's a compression of air. That compression of air will cause contraction at the surface. अगर दोनों जगह सेम salinity, otherwise salinity is also higher towards subtropical high pressure zone. तभी तो पानी का मोबिलिटी कहाँ पे होता है? इक्वेटर पर हो रहा है, सब पोलर रीजन में हो रहा है. वो सबट्रॉपिकल हाई प्रेशर में क्यों नहीं होता? Why we don't have ocean current circulation in the central region? Mixing of water is restricted because water is very dense. क्यों dense है? क्योंकि salinity ज्यादा है. क्यों dense है? क्योंकि ऊपर से compression भी हो रहा है एयर का. तो इसको हम ocean current में जब बढ़ते हैं तो right, and atmospheric pressure does play a role in ocean currents. Regions with a higher atmospheric pressure have less mobility of water. Less mobility of water would mean high pressure condition. Less mobility means is because of compression that experiences because of high pressure. And the mobility of water therefore gets restricted. Equatorial regions और subpolar region में ज्यादा पानी move क्यों करेगा? क्योंकि air masses rise करती हैं, दबाव कम है पानी पर और mobility is better है. Right? चलिए फिर इसको यहीं पर रोक देते हैं. Density, temperature और atmospheric pressure. Just to add some values for the next topic. Let's suppose we are writing about density of seawater. Just some values of density of seawater. And suppose the temperature of seawater is 30 degrees Celsius. और इसका जो salinity है, that is 35 parts per thousand. 35 parts per thousand. At this 30 degrees Celsius, कहीं देखा आपने temperature होता है पानी का? This horizontal distribution, do we have 30 degrees Celsius temperature of water? Nowhere. Only in Dead Sea. Only in Caspian Sea. Only in those zones we have a temperature of 30 degrees Celsius. Otherwise, it will be like 25 degrees Celsius on a higher side. Salinity is 35 parts per thousand. और 35 भी कहीं पर है, हर जगह 35 नहीं है. ये थोड़ा सा 37 की तरफ है. Generally देखो आप 34, 32, 33 degrees Celsius की temperature. Now, when you consider these conditions, you find that density of water goes up to 1.0217 grams per cubic centimeter. Right? 1.0217 grams per cubic centimeter. Decimal 4 ले रहे हैं. Conditions क्या लिया हमने? 30 और 35. We keep the salinity same, right? And we decrease the temperature of this water to 20 degrees Celsius. क्या होना चाहिए density? Salinity same. It should go up to 1.026 grams per cubic centimeter. अब थोड़ा और बढ़ा देते, अब 10 डिग्री तक ले आएंगे. Sorry, temperature कम कर देते. The density remains same. It may go up to 1.029 grams per cubic centimeter. Understanding? The change of the water density will be decimal point, but that is significant. So salinity is same, salinity remains same, but temperature is decreasing. तभी तो हम कहते हैं ना कि low regions or those waters which are in the lower region of the ocean bottom, they have a higher density. क्यों density ज्यादा है ocean bed का? क्योंकि temperature कम. Salinity may not be very high, but because of that low temperature and the internal compression of water, the density of lower layer is going to be higher. So when we study this ocean chemistry, there comes an equation जहाँ पर 3 variables को देखते हैं. We focus on 3 variables. What is पहला variable क्या है? Salinity. It keeps on changing latitudinally or because of sea water, ocean currents, river water, etc. Second variable is temperature. We have discussed factors which affect temperature. Since these are 2 variables, the third variable अपने आप बन गया. What is the third variable then? Density. All these are interrelated, but तीनों vary करेगा. These 3 variables. So when we have to represent this 3 variable thing using a line graph, अभी ये draw नहीं करेंगे. Understand this. So we draw temperature on one side, temperature on, let's say, this side, salinity on one side, and the intersecting lines will represent density. Intersecting lines will represent density of it. तो एक तरफ हम temperature represent कर रहे हैं, दूसरी तरफ salinity, और बीच में जो intersecting lines होगा that will be density of the seawater. So we get a diagram like this. We call it as TS diagram. Temperature salinity diagram. On one side we are representing salinity,
other side is representing
other side we are representing
temperature.
temperature, increasing temperature, और बीच में जो lines दिख रही हैं आपको, ये क्या represent कर रहा है? Density.
Density.
And you can see this density showing value like 24, 25, 24.5, 25, 26.
26 half.
What is it representing?
Density.
Salinity. अब 25 तो salinity होगा नहीं, आयरन का 6 है, या फिर किसी और का वैल्यू देखेंगे डेंसिटी, दे आर नॉट डेंसिटी, वी कैलकुलेट कोएफिशिएंट ऑफ डेंसिटी, इसको हम सिग्मा टी कहेंगे, वी कॉल इट एज सिग्मा टी,
Density coefficient.
दैट शोस चेंज इन सैलिनिटी, चेंज इन डेंसिटी ऑफ वाटर थ्रू चेंज इन सैलिनिटी एंड टेम्परेचर. सिग्मा टी डायग्राम और दिस वैल्यू दैट वी गेट is just to simplify this decimal point disturbance. देखो, अगर ग्राफ में रिप्रेजेंट कर रहा हूँ 1.024 grams per cubic centimeter, it becomes very difficult for me. या मुझे यहाँ रिप्रेजेंट करना 1.0245, it becomes very difficult for me. Instead of writing 24 or say 24.5 or 25 or 25.5, 26 or 26.5, ये रिप्रेजेंट करना मेरे लिए ज़्यादा आसान है than representing these 3-4 decimal points. तो हम क्या करते हैं, इसको कन्वर्ट करते हैं. Then we convert this as 1.027 grams minus 1 into 1000. Not okay? It's 1.0276 whatever is the value multiplied by 1000, so it is going to be 27.6. So it is not the density of water, it is a representation of density of water. So representation को क्या कह रहे हैं?
Coefficient of density.
Density. Coefficient of density. What is that coefficient of density? Just to make this cumbersome representation easier. So instead of writing 1.024, we are just writing 24. कैसे करेंगे? 1.024 को माइनस करेंगे 1 के साथ, ताकि डेसिमल पॉइंट इजी हो जाए. मल्टीप्लाई करेंगे किसके साथ? 100 के साथ, सॉरी 1000 के साथ. Why with 1000? Why not 100? Simply because we represent density at least till 3 decimal points. Otherwise, देखो, ये जो हमने पहले वैल्यू लिया ना, this if I represent only till 2, it becomes 1.021, और ये भी 1.02 हो जाएगा, ये भी 1.02 हो जाएगा. So it will not be a true representation because it will marginally change. Temperature change होने से, salinity change होने से, there will be a marginal change in density. Since it's a very very small change in the density, we represent at least for 3 to 4 decimal points. ताकि हमें चेंज दिखे, वरना 1.02 के ऊपर से डेंसिटी ऑफ वाटर होना ही नहीं है, इट विल बी ऑलवेज सेम. अब वो हम रिप्रेजेंट करें ग्राफ में तो और कॉम्प्लिकेट हो जाएगा. In order to avoid that, what do? We multiply it with 1000 and get a value. Here it is just representing density of water. तो चलिए अब डायग्राम की तरफ चलें. You understanding this? Okay. So let's read this diagram first. अभी ड्रॉ नहीं करेंगे. Maybe we'll draw it. ठीक है, पर इसको ध्यान दीजिए. Suppose salinity, temperature, these lines are called as isopycnal lines. Isopycnal lines. Isopycnal. Pycnal word is used for density. So isopycnal lines क्या होंगे? Lines that represent equal density of water. They are not showing that is not the density of water. That is just a representation of density. Coefficient of density sigma t. See हमने ये sigma t value लिया, right? Density क्या होगा यहाँ पर? 1.024. Density यहाँ पर क्या होगा? 1.0245. 1.025. So instead of that we are taking it. Can I continue?
Okay.
Diagram बड़ा critical होगा exam में draw करना. So one side salinity. Let's read this first line. It shows density of or coefficient is 24. Salinity कितना है? 33.5. Temperature is nearly 20 degrees Celsius. So density of water is 24, which is very low. है ना? बहुत कम density. क्यों कम है? क्योंकि temperature ज़्यादा है और salinity is low. Then as you decrease the temperature, आपने 20 से 15 लाया तो density of water should increase. It becomes 24.5. यहीं पर आप salinity को पढ़ो. How much is the salinity? 34.5. So any point in this line, कोई भी point इस line में density क्या दिखा रहा है? 24.5. This line suppose
25.
it is 25. Clear? 25. टेम्परेचर कितना होगा? लगभग 14 डिग्री सेल्सियस। और यहाँ पर सैलिनिटी कितना है? 33.5. Density will be 1.025 or say 25. I'm moving along with this line. Let's read it here. What is the temperature here? Around 15. Temperature थोड़ा increase हुआ है. Density same है. क्यों same है? Because salinity भी थोड़ा increase हुआ है. Let's read it here. Temperature has become 20. High temperature, तो density कम हो जाना चाहिए था. लेकिन density same है. क्यों same है? Because salinity भी increase हुआ है. You're clear? So these lines are isopignal lines. What are isopignal lines? Lines representing same density of water. तो ये lines एक चीज हमें ये ग्राफ हमें एक चीज दिखा रहा है यहाँ पर फिलहाल. It is showing that if you change the temperature, the density of water may remain same if the salinity is also changing. Say for example, if you increase the temperature of water and decrease the salinity, the density of water is going to remain same. ड्रॉ कर सकते हैं इसको? क्या? ड्रॉ करने में गलती कहाँ पर होगा मैं बताऊंगा उसको, बट पहले इसको रीड करते हैं इस ग्राफ. Let's suppose I'll pick any point in this graph. कोई भी एक point ले लेते हैं, 27 वाला लेते हैं. I'll pick here 35, 27 or this 26. Let's mark this as A. Point A. Read this point A. If I bring it here, temperature कितना लग? Near about 10. Not exactly 10, but let's suppose it is around 10 or 9 degrees Celsius. Let's suppose temperature is 9 degrees Celsius. Salinity around 35.3 or 35.4.
35 से 35 के बीच में.
Parts per thousand. This point A. हम क्या करते हैं कि salinity को same रखते हैं. Let's keep the salinity same and change the temperature. Let's suppose here. This is point B. Can you read point B? What is the salinity? 35.3 parts per thousand.
Temperature.
What is the temperature? Near about 14 degrees Celsius. 14 degrees Celsius.
15, 14.
And what is the density of water here? 26.
26.
Sigma T is 26 or 1.026 grams. How do you read point B? We read point B as 35.3 parts per thousand of salinity. Temperature is nearly 15 degrees Celsius.
14 degrees Celsius.
Density of water is 26 or 1.026. Okay. इसमें क्या किया हमने? Salinity same रखा. What have we changed?
Temperature.
Increase the temperature. If the temperature has increased, what happens to the density of water? Changes. You're clear? We'll jump from one Pignal line to another Pignal line. Let's suppose we reach here. कोई एक point choose करिए. यहाँ पर. How much is the density here? Let's suppose point C. Read the point C. क्या density है?
27.5.
27.5. We know that is 1.025.
35.8.
Read the salinity.
35.9.
What is salinity?
35.9.
35. Let's suppose 9 parts per thousand. Nearly 36 parts per thousand. Here, what is the temperature?
9 degree, 8 degree.
Temperature is 9 degrees Celsius. So, if you keep the temperature same and increase salinity, what happens to the density of water?
Changes.
Again increases. एक बार हमने salinity constant रखा,
एक बार temperature.
salinity constant रखा, और temperature को increase किया, what happens to density? Decreases. फिर हमने temperature constant रखा और salinity increase किया, the density of water changes or it increases. Right? This is what is called as PS diagram. Holland and Hansen had given this graph to represent salinity distribution, density distribution, and along with that, change in density of water. जब भी तीन variables हो, इससे पहले science students, biology students अगर कोई आप में से है, या फिर बाकी subjects में भी, sciences में, जहाँ तीन variables आए, like temperature, pressure, volume, हमने हमेशा इस तरह की graph draw की, right? जो independent factors हैं, उनको हमने x-axis और y-axis पे लिया, और जो interdependent factors हैं, उनको cross section में लिया. Okay with it? So this is what is mentioned by STS. अब diagram draw कैसे करें? तो diagram का explanation clear है. You can understand this. So I'm removing. We'll take some easy values जो आपको याद भी है एग्जाम के. लेकिन ड्रॉ करने में ना ये बहुत परेशान करता है एग्जाम. तो थोड़ा बहुत रेटाफिकेशन is important. Because I can draw this diagram, big deal. Draw कर दूँगा एग्जाम में ऐसा कुछ नहीं. एक तरफ मैंने टेम्परेचर लिया, ये सैलिनिटी लिया. I start from 0, 10, 15, 20. Right. On the other side, I'm taking it as 33.5. This is 33. This is 34. This is 35. This is 35.5. यहाँ 36 लिया. कोई बात नहीं. And it is the same here. ये भी salinity represent कर रहा है. And intersection line. तो मैंने लगभग याद कर लिया था कि 20 के आसपास मैं स्ट्रेच करूंगा तो पहला लाइन लिखूंगा 24. दूसरा लाइन में लगभग को 15 के ऊपर का 15 और 20 के बीच में एक लाइन ड्रॉ करूंगा लिखूंगा 24.5. Then 25. Then near about this point to the other point will be 25.5. It will be like 26. This will be like 27. This will be like 28. 29 तक जाना ही नहीं. I'll not go beyond 28. इतना काफी है मेरे लिए. So I somehow, but still there will be confusion in the exam. जब आप exam में draw करेंगे, so make sure that when you're drawing this line, 28 or 28.5 तक काफी है. इसके आगे जाने की जरूरत नहीं है. You can manage with this. Make sure that you draw corners carefully in this. और थोड़ा बहुत ना इनको याद रखना कि पहला लाइन हमने कहाँ से ड्रॉ किया है 20 के आसपास ड्रॉ किया है दूसरा आइसोपिकल लाइन कहाँ से ड्रॉ किया लगभग 16 के आसपास ड्रॉ किया है थर्ड कहाँ से 15 के नीचे करीबन 40 पे ड्रॉ किया यहाँ तक कहाँ लेके गए पहला हमने 34.5 पे लिया दूसरा हम 35.5 ऐसे करके चल रहे अदरवाइज बहुत क्लियर डायग्राम एग्जाम में ये नहीं बनेगा दैट्स व्हाई आई डिडंट टेक द रिस्क पहले मैं हर बैच में ना ड्रॉ कर रहा था डायग्राम फिर मुझे लगा व्हाई शुड आई यूज सब मेरे पास अवेलेबिलिटी व्हाई शुड आई टेक द trouble आप ड्रॉ कर सकते हैं you can draw that
Yes.
let's write down this first उसके बाद आप ड्रॉ करें या you want to draw it first
Draw it.
draw आप बहुत टाइम लगाओगे ड्रॉ करने में लिख लो पहले लिखिए TS diagram take the subheading TS diagram Helen Hansen HE लिखिए TS diagram take the subheading TS diagram Helen Hansen HELLEND Helen TS diagram take the subheading TS diagram Helen Hansen HELLEND Helen Hansen dash HENSEN Device TS diagram which relates dash HENSEN
Helen.
device TS diagram which relates to two characters together with three variables changing to two characters together with three variables changing first of temperature and salinity may be plotted together with intersecting lines which represent same density. Put a bracket, isopycnal lines. So these are often curved or nearly straight lines so these are often curved These are often curved or nearly straight lines in which temperature and salinity. These are often curved or nearly straight lines in which temperature and salinity changes together. Temperature and in which temperature and salinity changes together. Temperature and salinity changes together. Also, the point generally fall on well-defined curve that is TS curve, showing the temperature salinity relation. Temperature salinity TS curve showing the temperature salinity relation. Temperature salinity relation of surface water in that region. The temperature salinity relation. Temperature salinity relation of surface water in that region. So the density of water is represented in decimal points.
The density of water
is represented in decimal points to avoid cumbersome and impractical use presented in decimal points to avoid cumbersome and impractical use till 4 decimal. And is represented in decimal points to avoid cumbersome and impractical use till 4 decimal points. It is converted in manageable numbers. As coefficient of density. Here, can write coefficient of density sigma t equals to density 1.026 minus 1.000 into 1000. So it is density minus 1.0003 decimal points into 1000, so we get a value. Right? We can also use it till 3 decimal points. Usually 4 भी ले सकते हैं. मान लीजिए यहाँ पर, so it is going to be 36.5. That will be representing the density. Clear? So अब ड्रॉ करिए इसको. ड्रॉ. Done. बन रहा है. अच्छा मतलब मुझ पे यकीन नहीं है क्या? वो तो ठीक है. पर ड्रॉ करने में कितना टाइम लगेगा? तो ये तो वीडियो भी आपके पास होते होंगे.
ISO कितना है?
But trust me, I've practiced it so many times, yet I make a mistake. ठीक है, your efficiency is better, but still practice it well. No?
Yes, sir. Done.
Done. Artificial intelligence. Hey, you asked.
ब्रेक टाइम थोड़ा 10 मिनट. माइंडसेट चेंज करने का क्या है? बस वही है, कंसिस्टेंट रहो, थोड़ा थोड़ा मोटिवेट रहो. मतलब मोटिवेट मतलब तो ये अपना फैमिली को देख और क्या।
बस वही है, कंसिस्टेंट रहो, थोड़ा थोड़ा मोटिवेट रहो, मोटिवेट मतलब ये अपना फैमिली को देख और क्या। बस वही है, कंसिस्टेंट रहो, थोड़ा थोड़ा मोटिवेट रहो, मोटिवेट मतलब
एक ही माइंडसेट रखो, करना है तो करना है। एक ही माइंडसेट रखो, करना है तो करना है। एक ही माइंडसेट रखो, करना है तो करना है। भाई भी हमको देख रहे होंगे यार। अभी मत पूछना भाई, सुबह सुबह हम क्या खा रहे हैं। तो भाई भी हमको देख रहे होंगे यार। अभी मत पूछना भाई, सुबह सुबह हम क्या खा रहे हैं। तो भाई भी हमको देख रहे होंगे यार।
how to draw a TS diagram. Let's say take a white paper, take pen. Okay. मुझे last class में last पर बताना चाहिए था, so that at least I can leave. I made a mistake. मुझे पहले sort हो जाता था मैंने. Done. Let's see. Because if I keep waiting, तो कल भी हम यही draw कर रहे होंगे, right? Make sure that you practice it well. ध्यान दीजिए क्या. Same what I have explained earlier. We are moving to the same point. Let's pick one easy point in this. तो यहाँ चलते हैं. Point A. आप लोग भी वैसे ही लीजिए so that we can make a almost same explanation. So in your description, just write diagram में ये point A लिख दो, same point पर. Like in your description, right here, point A in the graph represents point A in the graph represents salinity represents salinity of 35 parts per thousand. 35 parts per thousand. Done. And temperature, my approximation में लिखो, approximately 15 degrees Celsius. Approximately 15 degrees Celsius. Sigma T is 26. We can also mention density instead of sigma T, 1.026. Done? ठीक, इसी के साथ हम यहाँ पर ले लेते हैं. Point A1. It represents point A1 represents salinity 35 parts per thousand. 35 parts per thousand. 35 parts per thousand. And see the temperature will be somewhere around 17 or 18 degrees Celsius. The temperature of 18 degrees Celsius and sigma T is, how much is sigma T here? 25. That means density has decreased with the increase in temperature, even if the salinity is same. Done? कोई और value लेते so that we can clearly end this discussion here. This is point A2. Read here. Point A2, it represents, that is, temperature is how much? Approximately 15 degrees Celsius. Temperature same रखा हमने, 15 degrees Celsius. Salinity approximately 36 parts per thousand. And sigma T, how much is the sigma T here? 26.5. 26.5. That means density has increased at the same temperature with the increase in salinity. Understand this A2 point? बहुत आसान है, गेम खेलते हुए जाना करते हैं. जैसे ऐसे ड्रॉ कर लिया, take a point, read it, एक तरफ मूव किए, move downwards, move northwards. Clear? TS diagram. So, reason for this TS diagram is just one thing, that it will help us to understand temperature. Please 8 and 5, so that we can clearly end this discussion here. This is point A2. A2. Read here. Point A2. It represents, that is, temperature is how much? Approximately 15 degrees Celsius. Temperature same account है 15 degrees Celsius. Salinity approximately 36 parts per thousand. And sigma T, how much is the sigma T here? 26.5. 26.5. That means density has increased at the same temperature with the increase in salinity. Understanding is A2 point. बहुत आसान है, गेम खेलते हुए जाना करके, जैसे ऐसे ड्रॉ कर लिया, take a point, read it, एक तरफ मूव किए, move downwards, move northwards. Clear? TS diagram. So, reason for this TS diagram is just one thing, that it will help us to understand temperature, density and salinity in a given range. बस इतना ही कहेंगे, nothing else we have to mention in this. You draw here, you mention all this, write down towards the next point. TS diagram acts as a useful tool to provide most valuable information about ocean chemistry. By means of TS diagram, temperature, salinity and density is easily organized. TS diagram temperature, salinity and density is easily organized.
Temperature, salinity.
Temperature, salinity and density is easily organized. And has been used widely in all ocean expeditions. अब यही आइसोपिग्नल लाइंस को सरफेस और सबसरफेस in ocean expeditions. अब यही आइसोपिग्नल लाइंस को सरफेस और सबसरफेस वाटर में ड्रॉ किया गया और we drew the same TS diagram for surface and subsurface water and found that there is a zone in the ocean bed, subsurface region where density is not constant, it is continuously changing. एक पॉइंट पर हमें डेंसिटी सेम आना चाहिए था, लेकिन ऑब्जर्व क्या किया गया कि this zone of water shows a continuous change in density. Surface पर salinity same है, it decreases with depth. Subpolar areas or polar areas, it increases with depth. Temperature decreases with depth. Subpolar areas, it increases and then changes with depth. What did we call this line as? ये जो बीच में लाइन आया था उसको क्या कहा था हमने? Thermohaline, thermocline या फिर halocline. Now we are representing the same as density, so it becomes pycnocline. Why pycnocline? temperature is changing, salinity is changing, can density remain constant? It's also going to change. So that part where density is showing variability with depth, changes with depth, is referred as pycnocline layer. तो अब हमारे पास दो layers है, तीन layers है, surface, pycnocline, and deep waters. Like in last class we had mentioned that deep waters, cline layer where the condition will change. ये pycnocline layer ऊपर वाली layers को surface water masses और deep water masses को easily मिलने नहीं देता. Because density is not same, it is keep on changing. So it restricts the movement of water, or it restricts the mixing of water between the upper layer and lower layer. Because the density is constantly changing. Even if the dense water mass wants to sink or salinity goes downwards, it will be restricted only up to pycnocline layer. So only at very few places these water masses can reach to the deeper layers. Surface water masses can reach to the deeper layers where pycnocline layer is weak. कहाँ weak होगा वो हम बाद में discussion करेंगे. So if pycnocline layer is not weak, it is not very strong layer, it's a very weak layer. The surface denser water masses will keep on sinking to the deeper layers. Otherwise जितना भी movement है पानी का वो इस pycnocline layer के ऊपर होगा या pycnocline layer के ठीक नीचे होगा. The surface water masses can become deep water masses only if this pycnocline layer is weaker. ये हमें TS diagram से information मिलेगा कहाँ पर ये weak है, that will anyways discuss in water masses. Now we are moving towards one very factual point: heat budget and salt budget of oceans. Very difficult to find out, but that will conclude our discussion on temperature and salinity. Heat budget and salt budget of oceans. Heat budget and salt budget of oceans. So first heat budget, ocean heat budget. Atmospheric heat budget में हमने कुछ देखा था. That is income minus expenditure. So we have already discussed some points in temperature, that the sources of heat in temperature in oceans. What's the source of heat? Primarily solar radiation. Second is friction. Third is biological changes, biological activities that takes place. Third can be miscellaneous and volcanic eruptions. ये चार sources are primarily: radiation, life, volcanic eruptions, friction. और एक miscellaneous होगा, मैं नहीं पता exactly. Spend कहाँ पर होता है heat? One is the movement. Ocean current अगर equator से poles तक जा रहा है, poles से वापस आ रहा है, तो movement होगा. Movement means खर्चा होगा, energy is going to get used. There will be some of the back radiations going from the surface of Earth. There's also the radiation that goes from the surface of Earth. Same thing, radiation also goes from water surfaces. Not as much as it goes back from the terrestrial sources, but then it does go. फिर कुछ sensible heat भी होता है. Some of the heat is transferred from continents to ocean, and some of the heat will get transferred from oceans to continents. Sensible heat. Biological organisms or living organisms will also absorb some of the heat of oceans, and then will be again miscellaneous. The process is same. कोई बहुत ज़्यादा इसमें struggle करने वाली बात नहीं. Percentages जरूर लिखेंगे हम. That is high. So on one side we are writing the gain of heat, processes by which we gain heat, and then the processes by which heat is being lost. और last पे एक equations लिखेंगे. That will be all about heat budget. Let's write down sources of heat. Sources of heat. Number one. First source of heat. What is the first source of heat? Radiation. First source of heat is radiation. About 99%, 99.4 be exact, 99.4% of heat in ocean is received by radiations. Is received by radiation. 99.4% of heat in ocean is received by radiations. Is received by radiation. Number 2, friction. Second is friction. The kinetic energy provided by wind, kinetic energy provided by wind is translated into energy provided by wind, kinetic energy provided by wind is translated into friction that generates heat. That generates heat. About 0.1%. 0.1%. Third source is the volcanic activity and radioactivity. Volcanic activity and radioactivity that provides heat to ocean. Volcanic activity and radioactivity that provides heat to ocean, contributing about 0.8%. That provides heat to ocean, contributing about 0.8%. Contributing 0.8% to heat. Then fourth is sensible heat. Sensible heat. The heat gained from atmosphere and continents. Heat gained from atmosphere and the heat gained from atmosphere and continents. Heat gained from atmosphere and continents, it's not accountable, it's very less. Heat gained from atmosphere and continents, it's not accountable, it's very less.
Not accountable.
Now, next is heat loss. ये सभी gain है, heat loss from our oceanic surface. Number 1 is evaporation. Now, next is heat loss. ये सभी gain है, heat loss from our oceanic surface. Number 1 is evaporation. Evaporation. The latent heat of condensation. Evaporization. Not condensation. Latent heat of vaporization carries heat from ocean surfaces. Vaporization, not condensation. Latent heat of vaporization carries heat from ocean surfaces to atmosphere. It is nearly 66% of heat. Nearly 66% of heat to atmosphere. It is nearly 66% of heat. Nearly 66% of heat. Next, method of loss, back radiation to atmosphere. Back radiation to atmosphere. About 14.5% of heat is lost here. About 14.5% of heat is lost through radiations from the surface. Third, radiations from the surface. Third is loss of heat through convection. Loss of heat through convection. Warm air mass in contact gains heat from oceanic surface. Warm air mass in contact gains heat from oceanic surface. Contributing to about 9% of loss. Contributing to about 9% of loss. Next is transportation. Unequal heating of oceanic surfaces causes meridional transfer of heat. Oceanic surfaces causes meridional transfer of heat through ocean current.
Meridional.
Of oceanic surfaces causes meridional transfer of heat through ocean currents that causes the loss of heat by about 7%. Next, biological interaction. By about 7%. Next, biological interaction. Biological interaction. The complex biological process. The complex biological interaction. Biological interaction. The complex biological process.
The complex
The complex biological process
biological
causes transfer of heat. Transfer of heat by 3%. By about 3%. Full stop. Albris. A-L-B-R-I-Z. Albris. Albris. Develop an equation.
A-L-B-R-I-Z.
Albris.
Albris.
A-L-B-R-I-Z. Albris.
Albris.
Albris. Develop an equation. Develop an equation of total heat budget. Of total heat budget. That is R. That stands for radiation gain plus friction plus volcanic eruption in radioactive elements plus sensible heat. Plus sensible heat is equal to
So count नहीं किया sensible heat को
heat loss through evaporation, heat loss through back radiation plus heat loss through convection plus heat loss through transportation plus heat loss through biological interaction. These are processes of gain of heat and this is a process of loss of heat. So heat budget exactly क्या बनेगा फिर? All this gain by radiation, gain through friction, gain through volcanic eruptions, gain through sensible heat minus heat given to atmosphere through latent heat, back radiation plus convection plus transportation plus biological interaction. This is the heat budget or heat budget equation. Can we relate to this? So जितना भी gain हुआ minus evaporation minus radiation minus convection minus terrestrial radiation, the transportation, and then minus the total biological interaction. But okay? Okay, याद करना इसमें I can't help. But you see that this is how equations can be drawn. Yeah, total interaction. Obviously, this is going to be surplus in case of tropical areas. अभी तो tropical waters poles तक आएगा. That's going to be deficit in case of polar areas. क्यों deficit होगा? Because radiation कम है. So main source is that. Then salt budget. Salt budget. See, more complicated as salt budget. In fact, heat budget portion is also very complicated than more complicated than we have the budget in atmosphere. You have all these other complications. But then it is more like a research paper that we have to present for a heat budget of a given region. एक general equation देखते हैं दोनों cases में और ये जानते हैं कि how do oceans maintain the amount of salt that they get. Otherwise, oceans should have got filled with salt by now. Millions, in fact, billions years में अगर continuous salt accumulation हो रहा है, और अभी तक तो पूरा salt हो जाना चाहिए. क्यों ये कम है? क्यों balance है? That is what salt budget is mentioned. So, first point in salt budget. अच्छा, where is the gain of the salt budget from? Terrestrial sources. I think this last class we had mentioned terrestrial sources we gain. Space से थोड़ा बहुत we can gain. Igneous rocks we can gain and biological interaction we can gain. But still, in the heat, in the salt budget, they say that 98% of the salt that we get in the ocean is from terrestrial sources. वो igneous rocks को ऐसा नहीं मानते कि igneous rocks कोई major source of salt है. पूरा salt budget उस point पर mention है और base है कि terrestrial sources से ज़्यादा salt आता है than volcanic eruption. 98% of salt is from terrestrial sources. तो जो हमने वो व्यू पॉइंट लिखा था इग्नेस रॉक्स दे आर नॉट वेरी सिग्निफिकेंट, आई थिंक 0.6% के आसपास टोटल सॉल्ट ऐड होता है वहां पर, बट दैट इज हाउ इट इज। एनीवेज सॉल्ट बजट में राइट नाउ rivers contribute how much 2.5 into 10 raised by 15 grams per year to 4 into 10 raised by 15 grams per year. How much 2.5 into 10 raised by 15 grams per year to 4 into 10 raised by 15 grams per year. याद है? In fact, so देखो ये जरूरी नहीं होता, it's not important for exam, I also understand that. And कुछ लोग मेरे factual points से परेशान भी हो जाते हैं, GS में खासकर, GS में तो वैसे ही परेशान रहते हैं, उसमें क्या कर सकते? ऑप्शन में भी है, अब आपको लगता है कि अब इतना गलती कर ही लिया तो क्या परेशान होना, 6 महीने निकाल लेते हैं जैसे तैसे। तो reading, but I find sometimes factual information very fascinating. Therefore I remember some things. तो मुझे बहुत मजा आता है ये सोचने में कि 4 into 10 raised by 15 grams of salt is carried by. Imagine करिए उतना salt अगर oceans में पड़ रहा है तो that's how you get used to it. Now sometimes you actual information को जब आप visualize करोगे ना तो बहुत मजा आएगा चीजों में याद करने में, सोचने में. But for some reason we don't pay attention to facts. क्यों? क्योंकि उससे ऐसा impression जाता है कि हम रटते हैं चीजें. हमें तो समझ में आया था कि